Hello, and welcome to our continuing discussion of sampling procedures and data collection methodology. Sure, you're at the edge of your seat. All right, so along with the convenient sample and the voluntary response sample, undercoverage is also what is called a sampling error. We're going to talk about the difference between sampling and non-sampling errors in a second, but let's first talk about undercoverage. All right, this is when some group, or it could be groups, of the population are left out of the process of choosing a sample. All right, so what does this mean? Well, let's say that you are choosing your sample based off of telephone numbers. All right, well, you have now missed anybody that has an unlisted number or does not have a telephone number. Right? Let's say you're conducting your survey by email. Right? You've now missed out on anyone that doesn't have an email address. So undercoverage is when some groups are just being totally left out of your process of choosing a sample. So you might be like, oh, I'm doing it randomly. I'm doing all this good stuff. But if the setup of your project or the setup of your data collection is such that you're leaving out entire groups, there could still be a problem, all right? And we call that problem undercoverage. All right, so it says, even if the sampling technique seems to be representative of the population, the data may still be unreliable. So you could be doing a stratified sample, you could be doing a cluster sample, thinking that you're doing everything right. And if you somehow systematically left out a group of people, your data is going to be bad and you might not even realize it. All right, so undercoverage is an issue that we have there. All right. The following are called non-sampling errors. All right, so let's take a look at what these are, and then I'll explain the difference between sampling and non-sampling errors. All right, so one is the non-response, and this is what I've been hitting on the last couple of warm-ups. This is when an individual chosen for the sample can't be contacted or refuses to participate. All right, so you set up your sample correctly, you followed all the procedures, you did everything the way you were supposed to, and then the person on the other side of the phone was just like, no, I'm not talking to you. No, I don't have any interest. Bye. Sorry, I'm eating dinner. Hang up. That's sort of a non-response issue, is when you did everything correct and people just don't want to participate. All right. Usually we get around that by trying to offer some sort of incentive to participate, but depending on how much money your project has, you may or may not be able to offer an incentive. And and those are the things that like become relevant when you're talking about real world data collection, but just seem sort of abstract when you're in like a classroom setting. Right? In a classroom setting, you're like, yeah, we'll just give everybody this or we'll give everybody that. When you're actually running a project and you're like, all right, here's my grant, here's my total budget, what can I actually afford to give? Sometimes it can be pretty difficult. All right, next is response bias. All right, so I'm going to put down incorrect. I don't necessarily mean incorrect because like if you're asking somebody's opinion, an opinion can't be correct or incorrect, but you'll see what I mean by incorrect when I continue here. All right, incorrect answers by the participants And then what I'm going to put underneath this is different things that fall under this umbrella. All right. So you might be getting incorrect answers because they're lying. Right? If it's a sensitive issue, people are known to lie. Do you do drugs? Yes or no? A lot of people aren't going to be comfortable admitting that one way or another. So they might give you an incorrect answer in the sense that they're telling you no when they actually do. And that's going to influence your results. One is confusion. So depending on how you're doing your survey, the questions might be verbal, where they can ask for a clarification, or they might be reading a paper survey, reading your question, interpreting it one way when you meant it a completely different way. So confusion regarding questions, and they're answering a different question than the one you meant to ask. So then you get an incorrect answer because they answered a question that you weren't actually asking. And then last but not least, there could be influence by the wording of the question. And I'm actually going to add to this order. All right. And this is something that I find endlessly fascinating. There are a ton of good books out there on this. One is called Thinking Fast and Slow by Daniel Kahneman. There's another author, Daniel Areli. I don't know if I'm pronouncing that right, but he's written things like, one of his books is called Predictably Irrational. And he's got like a few others that are of the similar sort of topic, but it's all like the subtle ways that we are influenced by our environment without even realizing it. So little things that can cause our brain to make decisions that we might otherwise not have made, and we don't even realize it's happening. And that's a big issue when you're conducting surveys. In a couple of ways. One, because it could influence your results in a way that you don't want to. And two, people use it sometimes to help them get the results that they want to get. And I'm going to show you an example of that in a little bit. But again, it's this idea that people can be influenced even subconsciously by the wording of questions, the order of questions, and other things like that. So with these down, now let's talk about the difference between sampling and non-sampling error. All right. Sampling error is generally something that you, the researcher, have screwed up when you were selecting your sample. All right. So like you missed an entire group. You were lazy and conducted a convenience sample. You did a voluntary response sample. Something in the design of your research, the design of your data collection, your methodology was flawed. All right, you screwed something up in that sense. A non-sampling error may or may not actually be your fault. Like you might design a perfectly good experiment, or a perfectly good survey. We're going to talk about experiments later. You might design a perfectly good survey and people just choose not to respond. All right. You might set up incentives and people might still say, yeah, I'm not interested. So not really your fault, but it still screws up your results. Now the response bias piece may or may not be your fault. If you poorly worded the questions, yeah, that's on you. If you used leading language, yeah, that's on you. But it still has nothing to do with the selection of the group. All right. So sampling errors deal with the selection of the group, how you selected the group, and did you do it correctly or did you miss something? Non-sampling errors are what happened after you've selected the group. Either they didn't respond or they gave you incorrect or misleading answers. and it could be for any number of reasons. All right, so let's just look at a couple examples here and label them as either sampling or non-sampling. So A, the telephone directory, which is another fancy way of saying the telephone book, which is another way of saying like who uses a telephone book anymore, really? Like just Google it. But the telephone directory is used as a sampling frame. Is this a sampling error or non-sampling error? This is what would be a sampling error. You know, some people may be unlisted. Now, just to go a little deeper in this, people being unlisted may or may not actually be a problem, right? It's the potential for a problem. What makes it a problem is if the people who are unlisted have some common trait, some common trait that's relevant to your study, because then all of a sudden you're missing this viewpoint or you're missing this insight because you're not talking to those people. If some people have unlisted numbers and those people are exactly the same as the people with listed numbers, then the fact that you're missing out on them might not actually be a big deal. It's only a big deal if those people that you're skipping or missing out on somehow differ from the rest of the population. Right? Then it could potentially skew your results. All right, a person cannot be contacted in 5 attempts. All right, this would be a non-sampling error. All right, you did everything correct potentially. It's just you couldn't get a hold of the person. All right, and specifically, this is a non-response issue. All right, and this one up here was under coverage. And then last but not least, interviewers choose people walking by on the sidewalk to interview. Again, this is kind of the convenience situation. And a convenience sample is reflective of a sampling error. All right. You're not really trying to randomize things. You're not really trying to be representative. You're just saying like, all right, these people are here on the sidewalk. This seems easy. And you're just talking to whoever walks by. But there's all sorts of ways that could, mislead you, especially depending on like what time of day you're standing out there. Maybe certain people, if you're standing out there during like 9 to 5, maybe the people that you're seeing on the sidewalk are going to be radically different than the people you would see from like 5 to 7 p.m. So again, there's all sorts of issues that happen when you use a convenience sample, but in general, we think of those as sampling errors because you did a poor job designing your data collection. All right, so let's take a look at an example here. So a survey paid for by the makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Here's the actual question that they asked. It is estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? All right. So it's important that when you see a statistic, you know what's behind the statistic. Because depending on how that stat was gathered, you may or may not have a lot of confidence in that number. All right. When we look at this question, the responder is being primed to think about this a certain way. All right. They're being told, that it's less than 2%. Well, less than 2% sounds like a pretty small amount. Like, wow, only 2%. But we could probably word this in another way. Like if we converted 2% to the amount of tons that was, all of a sudden we could make it sound like there's a ton of disposable diapers in landfills. So how you word it and what information you give your surveyor your survey respondent can affect how they respond. And then it goes even further and gives this contrast of like, oh, well, look at third class mail and yard waste and all of that. That's 21%, and it totally leaves out that, diapers are made of plastics that probably take longer to break down. And well, yard waste might be like grass clippings or leaves or things like that are going to be gone in no time at all. So, the question is being written in such a way to try to feed you the answer before they even ask the question. So it says down below, explain how the wording of the question could result in bias. Be sure to specify the direction of the bias. So the direction of the bias is pretty clearly against the ban. And the wording makes it seem like diapers really aren't that bad. All right, so, that's a pretty obvious example, but it does happen in more subtle ways. And it's these subtle ways that subconsciously influence you without you even realizing it. And when I say like subconsciously influence you, I don't necessarily mean it's going to cause you to totally change a long held belief, but it can move the needle a little bit. And when you're talking to thousands of people, if 20 of them are impacted by this question, that can shift your results in one direction or another. If 100 people are influenced, it can shift your results. So even if you are sitting there saying, well, I would never be influenced by this, first of all, you're wrong. And second of all, even if you're not, if the person next to you is, it can influence the results. And people, there's a whole industry around this of like designing surveys and trying to get results and how to best ask questions. And when we say how to best ask questions, it depends what your intentions are. Are you trying to get a certain result, or are you trying to get the most accurate representation of people's true feelings? So what I'm going to show you now, I like this one because it's pretty absurd. This is something that was sent to my mom. Hey, Mom. And it was I think it was like from the Arbor Day Foundation or something. All right. And it was a survey that got sent to her, and they were asking her to fill it out. And if we look at the questions here, there's like, what is your age? What is your education? What is your job? Or like, do you work? Do you have kids? And then let's look at section 2, because this might be my favorite. Have you ever climbed a tree? When you were a child, did you ever play under or amongst trees? Did you ever collect leaves, acorns, or pine cones for a school project? Or just for fun? Funsies, let's collect some pine cones. Do you ever relax in the shade of the tree? Do you think a sugar maple is an appropriate choice as the state tree of New York? Do you think in general, residents of New York care more about trees than people in the rest of the country? And then 11 is good too, because it says, which one of the following would you say is the single most important function of trees? Providing shade, providing oxygen, being a source of beauty, absorbing carbon dioxide to slow climate change, filtering water, saving energy by cooling our homes and neighborhoods, providing habitats for birds and animals. Now, I don't care if you think like saving energy is important. I think saving energy is great. But how in the world is that more important than, I don't know, providing oxygen? I feel like things would go real bad real quick if we didn't have oxygen on this planet. Just saying. Just food for thought. Anyways, the purpose of these questions is not because they actually care about whether you collected pine cones for fun. All right. What they are doing is they are trying to psychologically prime you. All right. They are trying to make you think about trees. They are trying to make you think about trees in a positive light. They are trying to dredge up positive memories you have of climbing a tree or building a tree fort or whatever. They want you in a positive mindset so that when they ask the real questions, you are primed to answer them in a way that they think is valuable. So, what are the real questions? The real questions are, on a scale of 1 to 10, with 10 being the most important, how important do you think it is to replace forests destroyed by fire? The real question is, on a scale of 1 to 10, with 10 being the most important, how important do you think it is to save the Earth's rainforests? They are psychologically priming you to feel very positive about trees so that when you answer these questions, you're more likely to give a higher score. And then when they report their results, they're going to be like, oh, look how important this is. We need to spend more resources on it. Or look how important this is. You know, this needs to be a priority of our politicians. And I'm not saying any of these things shouldn't be. Right? Again, like I said, I like trees. But their intent is to get you to rate these higher. And when they report the results, they're not going to report your answers to questions 1 through 13. They're going to report your questions to 14 and 15, where you have been psychologically primed to be leaning towards higher answers. And again, it doesn't mean that it's going to take you from a 1 to a 10, but maybe it takes you from a 7 to an 8, or an 8 to a 10, or a 7 to a 9, and it boosts your score up. And then their results look more impressive when they're using them in whatever media or literature or flyers or mailings they put out. And again, I have nothing against the Arbor Day Foundation. Seems like a great group. They're not the only ones that do this. All right. Pretty much everybody does this. If you actually ever stay on the phone with some of those surveyors and really pay attention, you're going to notice they ask questions to try to get you in a certain mindset. And then they ask the question that they really care about. Or they use wording to get you to feel a certain way about an issue. All right. There's a lot of studies on this. If you ask somebody if they're in support of welfare, a lot of times the answer is no. If you ask somebody, are you in support of helping those less fortunate than you or helping the poor, people say yes, right? In theory, those are the same thing. It's just one word has kind of a loaded meaning behind it, and it affects how people respond. So again, this sort of stuff happens all of the time, whether you're aware or not, and you're being influenced whether you're aware or not. So I just would recommend, like, really, when you're taking a survey, stop and think. Like, really don't just, because what they're counting on is they're counting on you just doing it real quick, not putting a lot of thought into it, and going through the questions, boom, 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 boom. And when you do that, that's when those unconscious biases take over. It's when you stop and really think about something that you're able to sort of combat those and really answer something the way you truly feel about it. All right. So again, I think it's an incredibly fascinating topic. A lot of great books out there on it, but it is used in surveys a lot to sort of help get the responses that the people are looking for. All right. What we're going to do now is we're going to kind of make a transition. So thus far, we've mostly been talking about surveys and gathering survey data. Now we're going to kind of shift a little bit to talking about experiments and conducting experiments. All right. Both are designed to gather data. It's just a slightly sort of different approach in kind of what you're doing and what you have to consider and some of the vocabulary that goes along with it. So let's see what we've got here. Observational study. Right? This is a study that, shockingly, observes individuals and measures variables but does not attempt to influence the results. All right. In contrast, an experiment is a study where the researcher deliberately imposes some treatment on individuals to measure their responses. All right, so an observational study is kind of, we just sit back, observe people's behavior, observe people's decisions, observe whatever, but don't try to actually influence the process in any way. We're just trying to see what people do. Where the experiment is, we're deliberately imposing some treatment, some external factor, and then we're measuring what impact that has. How does it change the responses? How does it change what we see? Now, this is the key part. Only experiments can show cause and effect relationship. It looks like I crossed that out, but I really just meant to underline it. So don't think that I'm crossing this out. It's important. Maybe I'll circle it and then it won't look like a cross out. But this is what we were talking about in Unit 3, where we said correlation does not equal causation. We can't show causation without a well-designed experiment. Now, what is a well-designed experiment? That's something that we're going to be talking about over the next couple of notes, videos. But for right now, we'll just say a well-designed experiment. So let's continue on. The lurking variable. All right, this is the reason why observational studies do not show cause and effect. And the lurking variable is a variable other than the explanatory variable that may influence the response variable. All right, so the lurking variable is problematic because if you're just observing people, there might be a unknown factor that's causing people to make the decisions that they're making. And if you're not measuring it, you don't really know that it's happening, right? And you might attribute it to something else incorrectly, all right? So it's a variable other than one of the ones that you're looking at that's influencing people's responses, and odds are you don't realize it's happening. And because you don't realize it's happening, you're going to give credit to some other variable that doesn't actually deserve it. All right. Now, what is confounding? All right. Confounding is when two variables are associated in such a way that their effects on a response variable cannot be distinguished from one another. One another. And then down below it says, confounding is the effect that lurking variables have on a study or an experiment. So when you have a lurking variable that moves in the same direction as one of the variables you're measuring, it then becomes difficult to say, like, okay, what's actually causing these response effects? Like, I'm seeing a change in my response variable, but I don't actually know what's causing it because there's this lurking variable in the background that's moving in the same direction as the variable that I am measuring. So it makes me think that I'm giving credit to the wrong thing. The classic sort of textbook example is the places that have the most deaths also have the most doctors. So does that mean that doctors cause people to die? Maybe back in the old day when they had some of their quack medicine. But no, in general, doctors do not cause people to die. Their lurking variable there is sickness. All right. Where there's a lot of sickness, there tends to be a lot of doctors, and there also tends to be more death. So it's not that doctors are causing the death, it's that doctors and sickness are confounding. They both move in the same direction. There's more doctors where there's more sickness, and it's actually the sickness that's causing the death, not the doctors. All right. So let's take a look at an example here. Does reducing screen brightness increase battery life in a laptop? To find out, researchers obtained 30 new laptops of the same brand. They chose 15 at random and adjusted their screen to the brightest settings. The other 15 laptops were left at the default setting, moderate brightness. Researchers measured how long each machine's battery lasted. Was this an observational study or an experiment? Justify your answer. All right, so a case like this would be an experiment. And the reason is the researchers applied a treatment, which was changing the brightness, and then measured the results. All right. An observational study would have been more like just giving out the laptops, telling people to use them, and then observing what happened. Did some laptops go down quicker than others? What were those people doing on those laptops? What weren't they doing? And kind of trying to measure it that way. Whereas an experiment, we're applying the treatment. We're saying, oh, no, we're changing the brightness and we're seeing what effect that has. All right. So kind of the difference between an observational study and an experiment. All right, let's take a look at another one. Does eating dinner with their families improve students' academic performance? According to an ABC News article, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey conducted by researchers at Columbia University. Was this an observational study or an experiment? Justify your answer. All right, so this would be an observational study because no treatment was applied. Basically, we didn't force people to eat with their families. All right. What are the explanatory and the response variables in this study? So if we kind of look at what we're reading here, the explanatory variable was, eating dinner. Or we could also think of that as number of meals, because eating dinner is just a yes/no question. More accurately, the number of meals. And then the response variable would be student GPA. All right. Explain clearly why such a study cannot establish a cause and effect relationship. Suggest a lurking variable that may be confounded with whether families eat dinner together. All right. So the reason we can't establish a cause and effect relationship is there could be other factors that are driving the results. For example, eating with your family might suggest higher quality food or better nutrition. I don't know about you, but when I was in high school, I wasn't the world's best cook. Most of the food that I made for myself was probably far less nutritious than the food that my parents made. So eating with your family might suggest better nutrition, which leads to better grades. So it has nothing to do with the fact that you're eating with your family. It has to do with the fact that you're eating better food. And if somebody were to give you that better food by yourself, you would have a higher GPA because you would be better fed, your brain would be able to focus better, et cetera, et cetera, et cetera. So it has nothing to do with eating with your family. It has to do with the better nutrition. All right. So these two, the lurking variable of nutrition is being confounded with this idea of eating with your family. So again, the family part is irrelevant, but since it moves in the same direction as this better nutrition, we mistakenly attribute credit to eating with your family when the credit really belongs with nutrition. So, again, I'm not saying that this is actually the case here. There might be another factor. Maybe there's something else you can think of, but this is just one example. So the idea here is that nutrition improves grades. And again, I'm not saying nutrition does improve grades. I'm just saying hypothetically. Not eating with your family. All right. So that's kind of this idea here. There can always be this other factor that's actually influencing the results and you don't realize it. If you were going to do this as an experiment, you'd want the kids eating the same exact food and then just force some of them to eat it alone and some of them to eat it with their family. Because then you've sort of controlled for the nutrition aspect and you've just said, all right, the only thing that's changing here is that some of these people are eating it by themselves and some of these people are eating it with their family. Does that actually make a difference? Or is eating with the family just proxy for something else? And that's kind of the idea here. All right. So last thing that we're going to wrap up with today is just some definitions that deal with experiments so that we can use sort of a common language when we're talking about these things. So some of these words I've already been using, and now I'm just going to put a definition to it. So the treatment is a specific condition applied to the individuals in an experiment. All right, so we've been saying treatments already, like it's basically what you do to the subjects and what you're changing to see if it has an impact. The factors are the explanatory variables in an experiment. So the things that you're sort of measuring to see if they have an influence on the response variable. The levels are the specific values of a factor. Again, a factor we just said is the explanatory variables. So the levels are the values of those explanatory variables. And then last but not least, the experimental units are the individuals to which treatments are applied. And generally, if we're talking about humans, instead of calling them experimental units, we just refer to them as subjects. Right? Whereas if it's non-humans, we might just stick with experimental units. All right, so that is it for today. Again, this is sort of wrapping up surveying and kind of talking about undercoverage, non-response, response, sampling, non-sampling, and then moving into experiments and some of the things that we have to worry about, and then some of the vocabulary that goes along with these. All right. So I hope this was useful. As always, let me know if you have any questions, and have a great day.